Hello, this is Professor Mark. This is Lab 4, Chemical Reactions and Equations lecture. So we have these properties for matter: mass, volume, color, odor, density, melting and boiling points, flammability, and acidity. On the right, we can distinguish the two types of properties of extensive versus intensive. And extensive properties is a way of saying if you increase the amount of the particular matter, the quantity of the substance will change, the property of the matter will change. Versus intensive property is no matter how much you add, the intensive property will stay the same. So for instance, for water, the density of water is always 1 gram per mil. If you have lots of water, if you have very little water, the density will still be 1 gram per mil. Same as the melting point. The melting point of water is 0 degrees Celsius. Whether you have a lot of ice or very little ice, in intensive property, you'll be indifferent on the amount. And this is the same thing we talked about in the previous lab about specific heat, where no matter how much of that piece of metal you have, the specific heat for that particular metal will be the same. On the left, we have physical properties from the mass to the melting point. And a physical property is observed without changing the identity or the composition, meaning if we have ice and we add heat and it turns into liquid water, we still have H2O. So we can always get back the original form of the particular substance. Chemical property, this is where when you do something to it, whether it be, for instance, a flammability test, so if you take a piece of paper, you want to see if it's flammable, you light it up, you won't get back that piece of paper ever again. It will burn. So flammability is a way of testing, is a chemical property, whether something will react with acid or whether it will react with base. Those are chemical properties. So let's take a look at some examples for you guys to try as we go along together. The first set of questions, is it a physical or chemical change? For instance, A, shovel rusting. That will be a chemical change because once you let the shovel start to rust, you cannot get back the original state of the shiny, clean new shovel. Question B would be, so let's put a C here for chemical change. Ice to water, that would be a physical change because once you get the water, you can go back to ice by removing the heat. So you can get back the original H2O. Therefore, this would be a physical change. Digesting food, as you know, it's an endothermic process. You get energy from this, but we're here to talk about a physical or chemical change. Digesting food is a chemical change. You don't get back the original food once you start to break it down. Lighting a match, also a chemical change. Once you light the match up, it's going to start to burn. You can't get back its original match. The frost forming on ice. This is sublimation, going from gas to solid. Again, this is a physical change because you can go back to the gas state. And photosynthesis, this is a chemical reaction where you have the plant. It requires oxygen, it requires CO2 and water and energy, light, to give you food and O2, oxygen. So that's a chemical change. The next set of questions, whether something is extensive or an intensive property. Length would be an extensive property because if you take, for instance, a piece of paper and you extend it, you're going to change its length. Color, whether you have a lot of blue paper or very little blue paper, it's still going to be blue. So that would be an intensive property. Concentration, whether you have, let's say, acid, you have a 1 molar solution of acid. Whether you have a lot of the 1 molar solution or very little, it's still going to be 1 molar. So that's an intensive property. And mass, as we mentioned in the previous slide, if you add more, you change the mass. Therefore, you add more substance, you're going to change the mass. Therefore, it's an extensive property. We move on to the second part of the lab, is chemical reactions. We're going to talk about this as well as we just talked about physical and chemical properties. We're going to head over to chemical reactions, which we're doing now. And then the last part, we're going to talk about the types of reactions. So here we have chemical reaction. Well, a chemical equation, just like a math equation. A math equation requires an equal sign. A chemical equation or reaction will have an arrow always. So as you guys know probably from lecture, on the left side you have reactants, on the right side you have products, and from now till the end of the term or the rest of your chemistry careers, you always have to make sure that equation is balanced. Okay, and we'll talk about this in the next slide. But again, the left side you have reactants, right side you have products. We have coefficients in front here, a 2 in front of the H2, a 1 in front of the O2, it's understood there's a 1 there, and a 2 in front of the water. So here we want to balance chemical equations. How do we do this? Here's an example of 2H2 plus O2 gives you 2 waters. We look on the left side and we see we have 4 hydrogen atoms. 2 times 2 is 4. We have 2 oxygen atoms. And on the right side, so let's write this down, 4 H's, 4 hydrogen atoms. We have 2 oxygen atoms. On the right, we have 4 hydrogen atoms. And we have 2 oxygen atoms. So we look on the left and the right, we have a balanced chemical equation. So again, balancing chemical equations, we need the same amount of particular element on the left to equal that particular element on the right. We take a look. Here we have, as I said earlier, we need an arrow sign for a chemical equation. Left side is reactants, right side is products. S is for solids. This tells us the state of the particular compound. We have L for liquids, G for gas, and AQ, aqueous, which means the particular compound is in water. The triangle here, in this case, when it's over the arrow, means heat is added to the reaction. So let's look at this example here. We have CH4 plus O2 gives us CO2 plus H2O. We notice here it's not balanced. We have 4 H's on the left and only 2 H's on the right. So the same chemical equation, we just established it's not balanced. When we're balancing equations, we should always leave the most simple compound, in this case the O2, to the very end, because we can technically put any number in front once the other elements in the rest of the equation is balanced. So here we see 4 H's on the left, we see 2 H's on the right, so let's just try and put a 2 here. Now we have 2 H's on the 4 H's on the right, we have 4 H's on the left. The carbon, we have 1 carbon on the left, 1 on the right. Let's look at the oxygens. We have 2 oxygens plus 2 oxygens has 4 oxygens on the right. So we should add a 2 here to get 4 oxygens on the left. We cannot change the subscripts. We can only change the, so the next slide, a balanced, when you say a balanced equation, you always go from left to right. So the balanced equation would be 1, 2, 1, 2. There's a diagram to support this. Let's count again. We counted our carbons on the left, 1 carbon on the left, 4 hydrogens and 4 oxygens. We have 2 molecules of O2 on the left, 1 molecule of CH4 methane on the left. And on the products, we have the same thing, 1 carbon on the atom on the right, 2 oxygen atoms, another 2 oxygen atoms is 4 oxygen atoms, and 4 hydrogen atoms. We can only change the coefficients, again, as I said, so we added a 2 in front of the O2, and we added a 2 in front of the water. Never change the subscripts. If you changed, for instance, this O2 to O3, you would get ozone, so that's a totally different compound. So you can only change the coefficients. Let's take a look at another case. We have sodium plus water gives us sodium hydroxide plus hydrogen gas. Take a look to see if it's balanced. I see right away, I see 2 hydrogens on the left and 1 plus 2, I see 3 hydrogens on the right, so it's not balanced. We leave the most simple one compound or element at the end, so we leave the sodium to the very end. So let's try. We just said we had 2 hydrogens on the left. Let's put a 2 here. So now that we have 2 hydrogens on the right plus another 2 from the H2, we have 4 hydrogens on the right. We have only 2 hydrogens on the left, so let's put a 2 here to make 4. Let's look at our oxygens. We have 2 oxygens on the right, and we have 2 oxygens on the left. And we need to add a 2 here because there are 2 sodiums on the right. Let's add a 2 here to make 2 sodiums on the left. And just in our answer, we have coefficients of 2, 2, 2, and 1. So when we're balancing equations, we write out the correct chemical formula. Next, we balance the equation. We make sure the same elements on the left as on the right. We can only change the coefficients, not the subscripts. And when we're checking the answers, we have to make sure the smallest possible set of whole number coefficients has been used. Meaning if I had an example, I'm just making up the element, we had A plus B gives, let's say, AB squared. If I were to balance this, it would be, let's say I balanced it, we got 2, 4, and 2. We cannot leave the answer like this. We must simplify to the smallest amount. So we would bring this down and divide the left and the right by 2 to give us 1A, 2B, and 1 AB subscript 2. Of course, we don't write 1. We assume there's a 1 there. So the coefficients would be 1, 2, and 1. So I give you guys a moment to try. You pause the video and we'll come back and give it a try. So here, let's look at the first one. We have here Fe plus Cl2 gives you iron 3 chloride. We leave the most simple one to the very end, which is the iron. And we see there's 2 chlorines on the left, 3 on the right, 3 chlorides. Let's put a 3 here. The common factor is 6. So now we have 6 Cls on the left. We need to put a 2 here so that there's 6 Cls on the right. And as a result, we have 2 irons, and we add an iron here, a 2 here to make sure it's balanced. So the coefficients would be 2, 3, and 2. In the case of number 2, barium hydroxide plus phosphoric acid gives us barium phosphate plus dihydrogen monoxide or water. The first thing we notice is there's 3 bariums on the right and only 1 on the left, so let's put a 3 here. We see 2 phosphates, 2 phosphates on the right. Let's put a 2 here to give us 2 phosphates on the left. And let's see what happens in terms of the hydrogens. So the hydrogens, we have 6 hydrogens plus another 6 gives us 12 H's on the left. 12 H's on the left. We have 2 hydrogens from the water, so let's add a 6 to give us 6 hydrogens on the right. So the coefficients going from left to right would be 3, 2, 1, and 6. The next one is a bit more challenging. You have to take the names and make it into compounds. So for instance, calcium sulfate, that would be CaSO4. Normally you would crisscross the Ca2 plus with the SO4 2 minus. You would crisscross them. You get a 2 and a 2 in the for the subscripts, but then you simplify to give us CaSO4. It reacts with aluminum chloride, so Al is 3 plus, Cl is 1 minus. When you crisscross the 3 plus and the 1 minus, you get a 3 here and a 1 beside the Al, but again, you don't have to write the 1. And the products are aluminum sulfate, so Al2, which comes from the sulfate, and SO4 3, because the 3 comes from the Al3 plus. When you crisscross, you get a 3 on the sulfate, and the other product you get is calcium chloride, a 2 here from the Ca2 plus. So when we balance, we see on the right side we have 2 aluminums. So we should add a 2 here to give us 2 aluminums on the left. This results in 6 chlorines on the left, and we need to add a 3 here in front, so give us 6 chlorines. And we're left with 3 calciums on the right. We need to add a 3 here in front of the CaSO4 to give us 3 calciums on the left. So the third topic is types of reactions. There are 5 types: combination, decomposition, single displacement or single replacement, double displacement, and combustion. So combination, this is the generic formula where you have element A plus B gives you AB, 2 things combining, 2 reactants to combine to make one product. Here are some examples. It's a good time also to just brush up on your nomenclature. Here we have the 2 sodium solids plus chlorine gas gives us 2 sodium chloride. Again, you should always check these equations are balanced. We have calcium oxide plus water gives you calcium hydroxide. So 2 things coming together to give us a more complex product. Aluminum plus bromine gives us aluminum bromide. Here we have a decomposition where we have AB breaking down into more simple products. Here are some examples. Lead 4 oxide gives us lead 2 oxide plus O2 gas. We have calcium carbonate breaking down into calcium oxide plus carbon dioxide. We also have hydrogen peroxide breaking down to water and O2. And you notice a lot of decomposition reactions, it emits a gas here. So we see bubbles in the photo, an emission of gas as well. Our third type of reaction is a single displacement, where we have A plus BC gives you B plus AC. So the A and the B switch places. The A replaces the B. And you also likewise you have A plus BC, where the C and the A switch places as well. If you can. So in our example below, we have here zinc plus hydrochloric acid gives us zinc chloride plus H2 gas. We have aluminum and copper switching places to give us aluminum chloride plus copper solid. And in this case, the aluminum and the hydrogen and sulfuric acid switch places to give us aluminum sulfate and H2 gas. A double displacement is when two compounds exchange partners with one another to yield two new compounds. So in this case, the AB plus CD will give us AD plus CB. So in this case, the A and the C switch places. You will encounter this also when you do precipitation reactions. We have a double displacement where one of the products will be a solid. So if we look at some examples, we have lead 2 nitrate plus 2 potassium iodide, giving us lead 2 iodide plus KNO3 potassium nitrate. So again, the PB and the K switch places to give us our products. We have here the barium chloride plus silver nitrate gives us silver chloride plus potassium nitrate. So again, the silver and the barium switch places. And we also have our final example, sulfuric acid plus sodium chloride gives us NaHSO4 plus HCl. So for the reaction so far is a combination, decomposition, single replacement, and double displacement. The fifth one is a combustion, where we have here, in our case, we'll just talk about a carbon compound, whether it be a match, whether it be wood, whether it be a human body, it has carbon. For it to burn, you need oxygen, and the products are water, CO2, and some energy in the form of light or heat as a form of energy. And in the lab, you also see magnesium being a combustion reaction as well. We'll focus on the carbon compounds. So in the lab, these are some of the reactions you'll be, if you have the lab in front of you, these are the corresponding YouTube videos to show the particular reactions. I'm going to give you some more instructions later on in the lab. So we'll stop there for now.